Hello students, welcome to BITSAT forum. This is Brahma, your reasoning faculty. Today our chapter is one of the important and interesting one, that is logical deductions. Okay, in some exams it will be mentioned, the same chapter will be mentioned as syllogism. Okay, so in this chapter how the questions will be, the question format is in this way. Some statements will be given, statement 1, 2, 3, followed by some conclusions, conclusion 1, 2. Okay, so if there are only two conclusions, how the options will be? Options will be like option A, only conclusion 1 follows but 2 not follows. Option B, only conclusion 2 follows but 1 not follows. Option C, either conclusion 1 or 2. Option D, neither conclusion 1 nor 2 follows. And option E, both follows. Okay, if only two conclusions are there, these are the standard options. Okay, right. But if more than two conclusions are there, as per our answer, according to our answer, one option will be available. Suppose there are three conclusions. Suppose if there are three conclusions, conclusion 1, 2, 3 conclusions, then how the options will be? Only conclusion 1 follows, only 2 follows, only 3 follows, 1 and either 2 or 3 follows, all follow, none follow. So in that way options will be given. According to our answer, one option will be there and rest of the options can be anything. Next, then what should be our approach to solve this type of questions, so statement and conclusion questions? Okay, our approach is this way. We have to process all the given statements. We have to process all the given statements combinedly, and we have to process all the given statements and bring them onto a common platform. Okay, from that common platform we have to verify each and every conclusion separately, individually. Okay, and how to decide whether the given conclusion follows the given statements or not. To say a conclusion follows, it should satisfy all the that is a common platform. Okay, it should satisfy the common platform. If a conclusion is true in this possibility, then that conclusion is true. If a conclusion is not satisfying this one, then that conclusion is fail. Okay, if there is only one conclusion, if there is only one possibility, means after combining all the given statements, we cannot give guarantee we'll get only one possibility. We may get multiple possibilities also, many number of possibilities also. Suppose we got two possibilities, right? Okay, after combining all the given statements, we got possibility 1 and possibility 2. So then how to decide whether the given conclusion follows or not follows? So we can say a conclusion is true only when it is satisfying both the possibilities. If it is following first one and not following second one, final result is not following. If it is following both, then final result is following. If it is not following the first possibility fail and second is true, then also it is not follows. And first is fail and second is also fail, then also it is not follows only. Okay, and this is the case with only two possibilities, right? But there may be any number of possibilities, no? There may be n number of possibilities. Suppose we got 100 possibilities after combining all the given statements, and the combined result we have 100 possibilities. Out of 100 possibilities, at least one possibility fail, means it is fail. If there is no such failure case, then it is true. Okay, 1 true, suppose second possibility true, third possibility true, so on, 99 possibilities true, but 100th possibility fail, then total result is it is fail only. Okay, so in this chapter it is easy to say failure case instead of compared to successful case. And even in this chapter our concentration is on failure cases only. If we can get one failure case, then confidently we can say this is a fail, this is not following 100%. And suppose if we are unable to find that failure case, then we have to accept it is true in all the possibilities. Got it? So conclusion follows means it follows in all possibilities, and conclusion fail means it is a fail in at least one possibility. Okay, all follow, then it is follows, then at least one fail, at least one failure case, then it is fails, follows and not follows. So this is the concept for statement and conclusion type, and not only for syllogism and logical deduction chapter, and wherever you find the statement and conclusion type question, this is the approach you have to follow. Process all the statements and verify the conclusions. Okay, right. Coming to this chapter, logical deductions. What is the format of statements? Statement formats. So in this, I think you might have seen some questions somewhere, anywhere in competitive exams or in entrance exams, like this one: all cats are dogs. Okay, all cats are dogs. This is a statement given, and actually, is this true in practical? In real time, is it true? All cats are dogs? No, but still we have to consider it as true because it is given in the statements. See, whatever mentioned in the statements, even though they are not true in real time, but we have to consider them as true because they are mentioned in the statements. By considering them as true, we have to process the conclusions. We have to verify the conclusions from those statements. Okay, so all cats are dogs. So for this, we can generalize in this way: all C's are D's. Cats I have represented here as C, and dog I have represented here as D. So all C's are D's. So then what is that C means? C can be anything. It can be a cat or chair or anything, and D, it can be a dog or doll or anything. Okay, so that means here the terminology here. First of all, in this statement, this all is called qualifier or quantifier, and this cat word is the subject of the statement, and this dog, the word dog, is object or predicate of this statement. I'm not teaching English subject. Okay, we are in reasoning only. Next, the word are is the linking word. It is just a linking word. Okay, so qualifier or quantifier, then subject, then linking word and object. So this is the general format of the statement, as well as conclusion also. Conclusion is also looking like the same. So I have generalized this one: all C's are D's. In this, our concentration is not on cats or dogs, because examiner can use any word which is available in this universe. The one who is setting the question can use any word which is available in this universe in place of cats and dogs. That's why we don't need to concentrate on these words, cats and dogs. And here it is just a linking word, and we don't need to concentrate on this one also. That means the total our concentration is on the word all. Here in this statement it is all, but in general total our concentration is on the qualifier. So that means we should learn the qualifier. Okay, and here how many qualifiers are there in total syllogism? In total syllogism there are 4 qualifiers. Actually there are many derived qualifiers. There are many qualifiers, but basically 4 qualifiers are there. The 4 basic qualifiers are The 4 basic qualifiers are: number 1, all; number 2, some; number 3, no; and number 4, some not. Other than these 4 qualifiers, and rest all are the other names of these qualifiers only, like synonyms we can say. Instead of using all, we can the examiner may use every. Instead of giving all ARB, we may have, in place of all, we may have every A is B, each A is B, 100% A's are B's. Instead of using some, few A's are B's, lot of A's are B's, at least A's are B's, at most A's are B's, generally A's are B's. Okay, so all other qualifiers are the either these synonyms of these 4 qualifiers or the combination of these qualifiers. So by combining 2 qualifiers also, we may get new qualifier. Okay, next, coming to the type of qualifiers. All is a positive qualifier and negative qualifier. All is a positive qualifier. Some is also a positive qualifier. No is a negative qualifier, and some not is also a negative qualifier. Next, yeah, tell me, all is an universal qualifier or particular qualifier? Yes, it is an universal qualifier. Some is particular qualifier, and no is no for all. That means universal qualifier. And some not is some not. Particularly, it is telling about some not. Few things are not. That means it's a particular qualifier. So finally, universal positive qualifier is all. Positive particular is some. Negative universal is no. And the negative particular qualifier is some not. So these are the 4 basic qualifiers we should be perfect with. Okay. Next. So to solve logical deductions questions, we follow this approach using Venn diagrams. We use Venn diagram to solve the questions of logical deduction. Okay. See, you already have an idea. I hope you have an idea on Venn diagrams, how to draw the Venn diagrams. First, let me give the diagram, and you have to give all possible statements for the diagram. This is A and this is B. What are the possible statements we can say for this diagram? Number 1, we can say all A's are B's. All A are B. Next, we can say some B are A, right? Here all B are not A, but some B are A. Some B are A. Next, we can also say some B are not A. No. Yes. This part of B is not A, no? Yes, we can also say some B not A. Any more possible? Yes, one more is possible. That is, total A is inside B only. If I take some part of A, is it belonging to B or not? Yes, it is belonging. That means we can also say some A are B. Some A are B. It is also possible, right? Next, yeah, tell all possible statements for this using those 4 qualifiers only: all, some, no, and some not. Using these 4 qualifiers only, we are saying the possible statements, all possible statements. So for this diagram, A and it is B. Here, yeah, we can say some A are B. This part, some A are B. Next, the same part is telling some B are A in the reverse order. Some B are A. And third is, what about this part? This part of A is not B, no? So we can say some A not B. And what about this part? Some B not A. Yes, some B not A. Okay. So these are the possible statements for the given diagram. Next one. What about this one? This is A and this is B. Tell all possible statements for this diagram also. Yes, one by one. Yeah, immediately we can use this one, no, because there is no intersection between A and B. So no A is B. No A is B. Second, no B is A. No B is A. Excuse me. Next is third. We can also use this part, this conclusion, right? The qualifier some not. How? If I take some part of A, if I take this part of A, is it belonging to B? No. That means we can say some A not B. Some A not B is also true. Some A not B. And what about the other one? What if that part is in B? Yes, this part of B is not A. That means some B not A. Some B not A. Okay, these are the possible statements for this diagram. Next one. Yes. What about this diagram? How many circles are there here? Yes, there are 2 circles, circle A and circle B, but it is looking like one circle because they got overlapped, exact overlap. So for this diagram, what are the possible statements? Number 1, all A are B, we can say. All A are B. Second, all B are A. All B are A. And third, what we can say? Yes, by considering this circle as A and I'm taking some part of A, is this belonging to B? Yes, the same part is belonging to B also because the both got exact overlap. That means we can also say some A are B, and similarly sum B are A. Here one observation is, wherever all is true, for that particular case sum is true automatically, right? Not only there, here also. Okay, and wherever no is true, sum not will be there automatically, because sum is the subset of all. That means all is the superset. It means if all is true, then sum will be true automatically. No need to check. If all is true in a particular case, for that particular case sum will automatically true. Similarly, one more is sum not is the subset of no. That means if no is true, then in that case sum not will be true automatically. Sum not will be true for that particular case. Right. So when the diagrams are given, you can identify the possible conclusions or possible statements. So then we will go in a reverse way. Reverse is I'll give the statement and you have to draw the diagrams. Okay. Yeah. I'm giving a statement like all A are B. All A are B. So what are the possible diagram for this one? All A are B. And one more diagram is all A are B. Two possible diagrams. Second, sum A are B. Sum A are B. So what are the possible diagram for this? Sum A are B in this way, right? Sum A are B. Yes, here also if I take some part of A, it is belonging to B. Next, what about this one? Sum A are B. Yes, that is true for this diagram as well. And one more diagram is also possible here. A is equal to B. Correct? You can go to the previous slide and you can verify wherever sum is there. And you can go with all those diagrams. Here sum is there, means this possibility exists. Here also sum is there, this possibility also, this diagram is also. Here there is no sum in the third case, and in the fourth case there is a sum. So in that way. Next statement. No, right? No A is B. Yes, there is only one possible diagram for this one, that is two separate circles, whatever may be their orientation. Two separate circles simply. And the last one is sum not. Sum A not B. Example statement. So then tell the all possible diagram for this. Yes, one is this one, sum A not B, and another is this one, sum A not B, and one more is this one, sum A not B. So show me the regions where it is. This part of A is not B, correct? Next, this part of A is not B, not inside B, and this part of A is not belonging to B, right? So these are the three possible diagrams for this sum not. And for sum, this is the region we have, and here this is the region we have, and here also this is the region we have, and here this is the region. And here completely no means no, there is no intersection between A and B. So these are the possible diagrams, but for each and every question we don't draw these many diagrams. For each and every statement we don't draw these many diagrams. We will draw only one diagram. And let me tell you the, okay, I'll take this space. Okay, here we have two types of diagrams. One is basic diagram, and rest all are alternate diagrams. One is basic diagram and rest all are alternate diagrams. So what is basic diagram? Basic diagram is the minimum overlapping diagram. And what is alternate diagram? Other than minimum overlapping diagram. Okay, so basic diagram is the minimum overlapping diagram, and alternate diagram is other than minimum overlapping diagram. So for each and every qualifier, how many basic diagrams will be there. Only one basic diagram. Now let us give the names for each and every diagram. First, qualifier all. What is the minimum overlapping between these two diagrams? Yes, first is the minimum overlapping, then declare this as the basic diagram, this as the alternate diagram. Okay. And second, what is the minimum overlapping diagram? The first one. First is the basic diagram, and rest all the three are alternate diagrams, ADs. Okay. And for no, there exists only one diagram that can be considered as basic diagram or alternate diagram according to your situation. And in the third case, what is the minimum overlapping diagram? See how to decide minimum overlap diagram. Between 1 and 2, what is the minimum overlap? Yes, first, because don't confuse with the word overlap. Okay, there is no overlap, but that means 0% overlap. Na? Here some overlap is there, existence, right? 0.1% or 1% may be there. So that means 0 is minimum or 1% is minimum, 0% is minimum. That means this is the first priority in selecting the basic diagram, minimum overlapping between these two. And between second and third, which is of minimum overlapping? Yes, from second and third, which is the minimum overlapping? Second, because in both the directions from A to B and B to A, it is some part only overlap. But here in the third diagram, from A to B it is some only, but from B to A it is some only, but from A to B it is all relation, right? So that means between these two, second and third, second is the first priority. And between third and fourth, which is the basic diagram, A is equal to B. So here complete overlap, 100% overlap is there. So finally, this is the basic diagram. In the basic diagram priority order, this is a first priority, this is a first priority, and then this one, and then this one, and then this one. This is the least overlapping, 0% overlap, and this is the highest overlap, 100% overlap, and these two are the moderate overlap. Okay, among the existing diagrams we have to decide which is the basic diagram. Between these two, in the first case, between these two, first is the basic diagram, second alternate. And for the second qualifier sum, first is the basic diagram because it is some part only, but rest all are having all part. And third, the same diagram, only one diagram means it can be considered as basic or alternate. But in fourth C, here there is some overlap, and here in the third figure there is no overlap. That means this must be our basic diagram. This must be our basic diagram, and the remaining these two are the alternate diagrams. Okay, so for each and every question we have to draw only basic diagram. We don't need to draw alternate diagrams. We should extend our analysis. We should extend our analysis for an alternate diagram only when the situation comes. Otherwise we can decide the answer with the basic diagram itself. Okay, so let us go to the questions, and before going to the questions, let me do the questions in the next class. Okay, see this concept twice or thrice. If you don't understand, then see this concept twice or thrice, because if you are clear with the concepts only, questions can be solved easily. If you do with the half knowledge of the concept, then if you attempt the question, it will go wrong. Okay, that's why I'm saying. So simply be clear with these things. First of all, when we can say conclusion is true or false, when we can say conclusion follows or not follows. And the second is, what are the qualifiers we have, and what are the basic diagrams for them, and what are the alternate diagrams for them. But concentrate on, be careful with the basic diagram only. Alternate diagram is not that much necessary. Only when the situation comes, we use the alternate diagram. I'll show where to use alternate diagrams and all those, but be careful and be clear with the basic diagram. Okay, so we'll meet in the next class. We'll solve the questions in the next class only. Thank you.